Hello again. This is Mark Summers from Summers Technical Services. We're going to do a three-dimensional force calculation from our Mechanics for Engineers class from Chapter 3. We've done the hand calculations already using the geometry provided in the problem. Now we're going to try to solve the same problem using Solidworks simulation. So as a reminder, here's a picture of the problem. We've got our traffic light with three cables holding up all three posts. And knowing the geometry and the mass of the light, we should be able to calculate the forces in the three cables, AB, AC, and AD. And comparing to the answers we got on the hand calculations. So let's see what this looks like in SolidWorks. So I've created a model already. It's a simple part model, and I'm just using the geometry. I created a 3D sketch we can look at here with all the pertinent information as far as the dimensions. So here's where the traffic light's hanging, and these are three post phantom lines here. And it's got all the geometry of the cables. And then I just created some boss extrudes, just some circles here. This is some steel tube. It's going to represent these cables that I'm assuming are pretty much no deflection, and you can't pull on them and extend them. So it's not like a rubber band, it's like a cable, steel cable. So we should have near zero deflections. And I'm going to assume this will we'll check the displacements to make sure that's correct. Another couple of things about the model. When you do these extrudes, each one of these extrudes is one of the cables, and there's one more here at the bottom so I can hang the weight on here in the middle. But when you do these extrudes, you got to make sure on the feature that you check this merge result checkbox on these features. This is not the first one. Starting with the second one, edit feature. First one's doesn't have that option. All the other ones have this merge result checkbox. It's usually checked on. Turn that off so we'll have four separate beams, and we can do a 2D beam analysis using SolidWorks simulation. Okay, so let's get started with SolidWorks simulation, see how this works. So I'll click on my simulation tab, and we'll start a new study. And I'll just call it static 1. Just leave that the same. There's lots of different options down here. We're going to do a static study. And we pretty much answer questions moving left to right and then run the analysis. So the first thing I need to do is tell SolidWorks simulation to simulate these solid bodies as beams instead of 3D objects. So just right click on each one of these individually and say treat as beam. We'll do that on all four of them. Treat as beam. Probably can do these all at once. Do it one at a time here. So now I've got three beams in there. You can see it creates the nodes at the ends of the beams. And so that takes care of that. And the first question is apply material. So I've already defined the material in SolidWorks part model, but I need to tell simulation module what it's made out of, and I just chose AISI 1020 steel, just something that's nice and stiff so I don't get a whole lot of displacements. So we're not looking for stresses, strains, we're just looking for forces. So I'll apply and close that, and the next button here is fixtures, so I'll pull this down and do fixed geometry. I want to fix these four corners. I'm assuming those poles are stiff and won't deflect very much. So I don't want to fix geometry because I want those ends to be able to rotate. So I'll say immovable, no translation, and it's asking for the node, and so that's the first one there. There it is, joint, and I'll say OK. And I'll go around the horn and do all of those. So fixtures, fixed geometry, we'll do this one. and we'll say immovable. And then this one over here will do the same thing. Fixed geometry and immovable. No translation, which means it can still rotate. Grab that joint and say OK. So now I've got 3 fixtures on here, and now I need to add my load, and I want to add my load to this node right here at the bottom. So I'll come up here and say loads force, and it'll pop up my dialog box. I want to choose nodes or joints, and I'll choose that joint right there. And units SI, and I want to go, I got to define a direction. So I'll grab my plane that's the floor, which I believe is his front plane. So that'll define the direction. And I want the force to go normal to that plane, straight up and down. So I'll click this button here. And if it's a 15 kilogram traffic light, I'll multiply mass times acceleration. And that'll give me my newtons. And it's guessing the wrong way. It's pointing up. I want it to go down, so I'll reverse direction. And I'll make this symbol a little bit bigger so I can see it maybe. Oops, maybe not that big. And say OK. And there it is right there. So now I've got my material defined. I've got the fixtures on the nodes out here. I've got my load applied, and so now I think I'm ready to run. So we'll just hit run this study, and it's going to run extremely fast because the with 2D, I guess, or 1D beam element, 1-dimension beam elements, it can mesh it very, very quickly. So this is much quicker and faster than doing a 3D model. So there we go, showing me displacements. Let's edit this result that it gives me here, and let's just look at the vertical displacements, which would be Z direction. And I'll change that over here, and millimeters, and then we'll take a look at the numbers up here, and I'll turn off this deformed result. And that is not what I'm looking for. I'm looking for a displacement. There we go. So displacements are near zero. These are 6 meter, 3 meter long, thousands of millimeters long. I've only got tenths of a millimeter deflection, so that's good. So my assumption about the displacements was correct. So now what I want to do is ask for the beam loads. So we'll right click on results and click on list resultant forces. And we'll get a pop-up here, and I want to ask for, I want the resultants at these fixtures here, or at these corner joints. So 1, 2, 3. There's the third one. There they are. And reaction force, I'll hit update, and I get a nice little display here of all the corners. And so there's one up there, and there's one over here, that node there. And so based on my picture, we can see which one is A, B, AC, and AD. Drag this over here where it belongs. Okay, so it's giving me X and Y components, but I want that resultant force. That's what I'm most interested in, because that's the total force in that cable. And so we got 221 newtons in this one, 515 newtons in this one, and then 441 newtons on that one. If we look back at our results we got with our hand calculations, that's very satisfying. They all match the results we got with the hand calculations. So hopefully that was informative, showing you how to use Solidworks to do some of these cable force calculations, which can be complicated, take a lot of time with hand calculations. If we've got a model built, of our system already, then we can quickly do a SolidWorks simulation, static simulation, to calculate those same forces. So that's all for now. Look for upcoming videos on other similar problems from our Mechanics of Materials class. And until then, enjoy your evening. We'll see you next time.